average slope between 2 points. I don't know if you pick that up or not. It's not necessarily easy to see that. Some of the problems you have to do the quotient. What's it called? That thing. The f of a. Blanking on the word. F of a plus h minus f of a. You guys did it last year when you like expand everything and things cancel. And what's that freaking called? Yeah. But anyway, the good news is you don't have to do it again. I'm going to show you how to shortcut it. Kind of cheat our way around it. And it's not like the AP Touch kind of expects you to. It's not like cheating. But so some of the problems on here ask for those, and you don't have to do it that way. So that might be why part of them were confusing. We'll talk about why as we go. So we are getting into tangent lines versus secant lines. Average slope versus instantaneous slope. So what you have always done up until this point in math is find the slope between 2 points. We have a point there and a point there. And I can find the average slope between them. But like let's say this is a position graph. Then I'm able to find the average velocity between these 2 points. But what if I want to know the instantaneous velocity at this exact point, like at this one moment in time? I'm not saying between like here and here. I'm saying at that one moment in time, how fast are you going in that snapshot? So that is what's called the tangent line, where it's just 1 point. You guys have drawn these, right? Like we did a little bit of that in the first unit. So the tangent line is like the surfboard guy we've talked about. So if you could draw a little guy on here, and you're surfing along this wave, it's like the line that surfboard would be. So calculus was apparently invented by someone trying to figure out how fast the Earth revolves around the sun. And then accidentally, so imagine this is like the Earth's rotation. I know it's not a circle, but. And then at this exact moment in time, gravity stops existing, and he stumbled across, where would that Earth go? If there were no more gravity, all of a sudden you would just keep going along this line. That's the tangent line. I think I told you the story when I decided it'd be fun to like test the brakes on my Ford Aerostar minivan in the snow. Same idea. I'm going along a curve, going around a curve, and the very lightweight minivan with nothing in the back, I decided to just pull up on the emergency brake because I was 16 and an idiot. And what? It was last year. And you just lose traction, so you're not going along the curve anymore. You just start like skidding, and then there was like a tree over here that stopped my skid. But that's the idea. Like you're going around a curve, and then the curve stops existing, and this line is the tangent line. So then the question is, how do we find the slope of that tangent line? And what we do is use the secant line to estimate it. Secant is 2 points. But what happens with limits is we can let the distance of those 2 points become smaller and smaller and smaller. So the green line is the secant line. That's your average velocity. This pink, is that pink? Gotta help me with colors here. This is green, right?
Yeah.
Black?
Yeah.
Blue?
Yeah.
Black?
Yeah.
Nailing this. All right. So, yeah. So, if we take that second point, this point up here, and I'm still finding the average velocity, the average slope between those, but like, look what's happening with the point. As I get that point closer and closer to the other one, am I getting closer to the exact instantaneous tangent velocity? I am. So what calculus says is let's let the distance or the limit of those two become 0. So the points never actually touch. Like you can see they're still 0.01 apart. But they're so freaking close that they might as well be touching. So like, would you say that's a fair representation of the instantaneous velocity? Even though it's not technically instant because we're 0.01 or 0.0001 apart, we can say it's basically the instantaneous velocity. So These are two different ways it's written. And these are just slope formulas. So this is like y2 minus y1 over x2 minus x1. In this case, it was actually this. Then the a's cancel. But these are technical definitions of the derivative, which is what we're doing this whole next unit. And they're just slope formulas. They're the slope formula, but if you think about h as the distance between these 2 points, h is going to 0. So if the distance between the 2 points is going to 0, that's essentially just me just sliding this point closer and closer so that this instantaneous is more accurate. This is literally y2 minus y1 over x2 minus x1. Just slope, but I'm letting x get closer to a. Well, if x were a, the bottom would be 0. But if I let x just get really close to a, then the distance between them is getting smaller and smaller and smaller. And last year in pre-calc, you guys had to plug in and do algebra to work all these out. We don't have to do that because we're going to learn how to actually take a derivative. And you can look at an equation. You can look at this formula, tell what they're asking you to take the derivative of, and take the derivative like the shortcut calculus way, instead of this long process that you did last year. I still can't remember the name. The difference quotient?
Yes.
Yeah. So if you remember, you were doing like x plus h squared minus x squared over h, and then you had to like expand everything. And then, like, those go away. 2x h plus h squared over h squared. Then an h goes away. So you get, like, 2x. So you end up with 2x. Well, I know instantly, in, like, 5 seconds, the derivative, like, 0.5 seconds, the derivative of x squared is 2x. There's a shortcut for that. It's super easy. And what you'll eventually learn is, oh, whatever's there in that formula is what they want me to take the derivative of. I know how to take the derivative, so let me just skip to it instead of doing that entire difference quotient process. So what we're going to practice today is identifying what's in those spots. We haven't learned to take a derivative yet, but we're kind of working our way up to that. Let me just, might as well show you a little bit. That means derivative, a little prime. The derivative of x squared is 2x. The derivative of x to the third is 3x squared. The derivative of, let's say, 5x to the fourth is 20x to the third. Could you tell me the derivative of a times x to the n power? Don't say it out loud. I should write that on the actual whiteboard so that, you know, because I'll get like tons and tons of views on my video. So for those of you following along at home here, I'm saying if y equals x squared, I know the derivative is 2x. If y equals x to the third, the derivative is 3x squared. If y was 5x to the fourth, the derivative is 20x to the third. If I told you y was a times x to the n power, could you tell me the derivative? Don't say out loud. I was just rehashing for the home viewers. You think you got it? Everybody think they got it? Yeah, go ahead. So you bring down the power, you multiply by the number in front, so a times n, and then you just reduce the power by 1. That's the derivative. So the point of that is if you are given like limit of x approaches a of x to the third minus, it'd be like 3 to the third. This would be 3, let's say, over x minus 3. You can do the difference quotient. You can like work with other things if you want, but really, in this formula, whatever goes there is the original formula they're asking about. So I know they're asking me about y equals x to the third. So what's the derivative of y equals x to the third? Is that one? It's 3x squared, and we were just able to skip through that entire difference quotient process. And that may or may not have made a ton of sense the first time we're doing it. Like, I get that. But I'm just trying to convince you that we don't need to do the difference quotient. We can kind of skip past it. I got a little off track. The question on anything I just said, I'm a little off track, but I would like, if there's questions on it, so let's start looking at your problems a little bit. I'll kind of show you what I mean. Some of the stuff I was talking about. So these are examples. These are examples of the type of problem I'm talking about where we don't have to do the difference function, the difference quotient. They gave me two different forms here, and I wrote the two different forms on the board. It's kind of, shall I rewrite it bigger? Can you guys see it? Like, Waleed and Ethan, can you see? Oh, it's in your book, right? Okay. So see if you can look at, this is at h approaches 0. So it's going to be the top one. Can you look at that function and tell me what the original function is? So the question is, if I were to say y equals this, before we plugged into the quotient formula, what was it? Let's see if you can tell me that. I think it's easier on number 2. We'll practice a couple more too. I don't know how to teach them. I just like to show people examples and eventually you get it. I don't have any magic teaching methods here. Yeah, I'm just gonna like hope it like absorbs it. So the second one I think is easier. If I look at, so x is approaching a number instead of 0, so that's going to be this formula. So f of x is what's on the top left-hand side. So literally whatever is right there. That was the original function. And they're asking for the value of it wherever x value they give you. Do you see where I'm getting that from? Not necessarily you could have gotten it a second ago, but is it when I show you, are you like, okay, yeah, that clicks? Or not necessarily? See, okay. We'll do a couple more. This one I think is a little tougher because now you got this formula, you got like the A and the H and stuff. So this is always going to be the original equation, except it's going to have the number that they want you to use there instead of x. So the original equation here is going to be 5 times ln of x. Because the 5 and the ln are in like both spots there. Kind of what got replaced was the x, and it got replaced with a 1/2 in this spot, so that's what goes here. You see what I mean? Like I'm teaching this terrible, but when I show you examples eventually, I think you'll get it. Yeah.
On the notes it says 4 for the instantaneous rate. I don't know why. They don't
Is it 4 there?
Yeah, he said 4. And I was like, and then I think it was 5 ln 2 over x. Which I like, I have no idea. That's why I was so confused. Where's he get 4 from?
So he said 5 ln 2 over 4, or x plus h.
2 over x.
2 over x?
Yeah. Which is like, that's weird. I don't get it.
I think that's right.
But isn't it, okay, if you're looking at the side over the side of 2,
So it's a hat. That's what you're saying. Or is not what you're saying?
Well, I guess that is what I'm saying. So I guess that yours is right and previous 2 over x is right. So x approaches 4. 2 over 4 is a half. So if you put 2 over x.
But we're not approaching 4.
We're approaching 0.
We're approaching 0 for age.
So
Like to me, like this is f of a.
yeah.
This is what you get when you plug in a. So what did we plug in there? We plugged in a hat. Yeah. I don't think this is right.
So where does the 2 over 4 plus h? What does that do?
That's like after I plug in h, and that's a different deal that I don't necessarily need to get in. I don't want to get into that part. I don't want to like get too bogged down on this question.
If you're confident that he was wrong, then you're right.
Yeah, 1/2 is.
Yeah, I guess
No. Let's look at a couple of
Celebrity.
Wait. So should we just leave 1 on the answer?
Sure. Let's just look at more.
I'm just gonna leave it how you
Photo maps. This is the answer of all.
So for 23, what does he say? 3 ln of x and x is
Evaluated.
23 on the practice. What does he say? 3 on the target.
Oh, so that makes sense. So why is the other one like snazzy?
It's like a. I see it.
I think 2 over x and 1/2 are the same.
Maybe X and R thing is full. Maybe X. So like if you see an H, you stop when you see an X.
Okay, that was terrible. I would sit like this. There was like moldy cheese. That one was bad. The back was crazy. The back was terrible. I was literally like either
So did he say it was 2 over 4 plus x?
No, he said 2 over X. Like where'd the 4 go? And then he was like, it's
2 over x and x is 4?
Yes. Yes.
I'm getting there.
Wait, why don't you just skim through the video and see what he wrote? Like, not listen to it, but just like look and see what he wrote.
Like, I'm clearly missing something. I'm just trying to figure out what it is. I don't know. I'm almost there. Give me. FYI, if this would have happened to me like my first year of teaching, I would be literally having a panic attack right now. Like, there's 15 students that looking at me. I'm not sure what I'm doing. This is the worst thing that could ever happen in my life, and I might have died. But I'm like, nah, I'm like, whatever. I don't care.
it's not like you know
laugh.
I know, but you should expect your teacher to know how to do it.
I was about to say that. Does anyone know what they're doing when it comes to calculus?
No. A is
5 ln 2 over x, and x is 4.
yes.
Okay, I get it. I was wrong.
He's got it. Say the words.
So, did this kind of make sense? Like y equals sine of x? X is a half. X is 5 or 2. Those are kind of. Let's do those first. Let's knock those out first. Then I'll come back to the like goofier things. Go down to like 21. So I can tell that's the kind that's easier because x is approaching a number that's not 0. And when that's happening, so when x approaches a, you're just taking f of x is just the thing in that spot. So in 21, can you see that f of x is 1 over the square root of x squared minus 2x?
Yes.
And then what is x equal?
7.
X is going to equal 7. So do 22 and 25 next. And 27. And I don't know if you can tell, but those are the only kinds I've ever seen in the AP test. The other kind I've not seen.
Okay,
If
good.
you hadn't
because I
noticed. Thank you for your patience while I learned the materials in the class. What?
It's better you figured it out than us trying to figure it out.
It's also like,
You should
it's
say
not
that.
hard. Like, that's okay to get them all right.
Just to trip it. You guys are AP students watching YouTube videos.
We good or not yet? So for 22, it's going to be the 3x minus 9x squared, and then what's x? Negative 2 because of that. Those are fine?
Yeah.
We're going to, like, should I even go through the other two, or we're good? I mean, I'll just go. Okay, so then for this one, your function is this guy. 6x squared times sine of x, and then x is going to be what that is, so pi over 2. And then for this one, it's going to be 1 over the square root of 3x. Then x is 5. Those okay?
Yeah.
So, just to like kind of circle back to what I was mumbling about over here, if I give you this equation, like if you got that, one way to do it is go through the entire difference quotient and start canceling and factoring. But I can look at that and you will be able to in like a week and say the derivative is 3 minus 18x, and I'm done. So follow the rules I just showed you. 1 times 3 is 3. Then you put the x, then if you reduce the power by 1, what's x to the 0 power? 1. So that's where that comes from. 2 times negative 9, negative 18, and then reduce the power by 1, so that's where that comes from. You don't have to understand that for like a week. I'm just trying to like fast forward. Did you do
We did like
derivatives?
one day where we like touched on it a little
Okay.
bit, and then
I remember not.
we definitely did.
But it was like 1 or 2. Okay.
We did like a workshop, but we did like
So let's go back to this other one up here, and then we'll practice those two. So number 1 up here. So here's the rule.
Okay.
Wherever you see the number plus h, so replace the number plus h with x. So this is going to be sine of 2 over x. So we plugged in a number plus h. That's a plus h. We plugged it in place of x. So wherever you see the number plus h, originally before you plugged in, that was an x. And then the number that's there is the x. I'll do a couple more. Click that in place. Yeah,
Is that
I forgot. That doesn't say sine, does it? See how I kind of think it says sine? Yeah.
Is that not the same thing that you did? Because if x is 4, then it's 1/2 in x. Is it not the exact same thing that you did?
2 over x.
Well, I said 5 times
ln of 1/2.
ln of x, and then x is a half.
So is it not the same thing?
Like, you might end up with the same, but it's not the same function. If I'm asked what's the function, it's a
very
different
good. Yeah,
function.
right.
Right. We're gonna try it. We're gonna do these more of these. We're gonna go to number 24 now.
Yeah.
24. So I must have plugged that in place of x, and I must have plugged that in place of x. So my original function is 3x squared. This is gonna be minus 7x plus 1. Because then the 3 is like this part. The 3 is, I subtracted what I got when I plugged in. Hey, so hold on. What's A? Let's start there. Like, what number is it?
3.
It's going to be 1.
Yeah.
Because that's the number that's in that spot. So this 1 plus H got plugged in for X. So that means two things. It means the X goes in that spot, and it means the number that we're worried about is 1. So, if this is my original function, which I'm claiming that it is, when I plug in 1, what do I get? Agree? So that plus 3 is really minus a negative 3. Here's the thing, this doesn't really matter. Like, you're going to learn derivatives and you're going to be like, why do I need to know any of this crap? So I'm like fighting this battle, like to figure this out and explain it to you, but in my back of my head, I'm like, I don't really care. But I care if you
I
care.
don't care if the negative 3 is a plus 3.
It's not. It's this minus sign, negative 3. So minus negative 3 turns into plus. So what I care about, just because I know what's coming, is you can do these kinds. And I don't really care about the other kinds. So yeah, so can we, if that got fine with you guys, and we just like
Yes.
move on?
Yes.
Are those okay? Those are all good?
Yeah.
Okay.
28 is terrible.
28 is e to the 6x plus 1. But all I'm doing is replacing 3 plus h with x.
Well, you don't need to know those ones, so let's stop asking
Wait.
questions.
Okay. Is it the first section, or is it just the whatever section is the whatever plus H?
Oh, that's gonna be the same.
Oh, it's gonna be 6. Okay. So does it matter?
My question
Or like,
last year.
I don't even know. It's fine.
Okay, let's-
We'll move on.
Now, I want you to go to number 15 through 20. And do this.
Oh,
What's going on?
We are. We're not doing those because in like 3 days. That was you good? So it's not that this isn't something we're going to learn. It's just you're going to learn a much easier way to do it in 3 days. 2 days, 3 days. I don't know. At some point soon. So don't think I'm like ignoring material. I'm not. I'm just. It's going to give you an easier way to do it. Okay. So now this match. Yeah, this match.
Okay, cool.
So average rate of change, but average rate of change is just slope. Like this is really like an advanced algebra problem at this point. So when you're dealing with 2 points, that's just the slope between 2 points. That's regular slope. That's the secant line. When we get down to the instantaneous slope, that's calculus. That's the difference. Average slope is like algebra, advanced algebra. Instantaneous slope is calculus. In physics, there's like calc-based physics and algebra-based physics, right? So that's the difference there too. In calc-based physics, you can get down to like the instantaneous velocity, acceleration, all the things like a snapshot in time. Where in algebra-based physics, you're looking more like an average over a time span. So this is average. We're not doing. Yeah, okay, so we're doing find the average rate of change. Average rate of change is just the slope. Slope between 2 points. You might be thinking, well, they didn't give me 2 points. They gave me 1. If you're thinking that's 1 point, you're wrong to start with. But it is right that you don't have enough information. These are x values. So they're telling you we're looking between like -1 and 3. So they just gave you 2 x values and no y values. And said find the slope between those 2 points. So what do we do to start that? I can plug in the x values to get the y values, right? So if I plug a -1 in here, 1 minus 2 gives me -1. If I plug a 3 in there, 9 minus 2 gives me 7. And then you're doing like good old y2 minus y1 over x2 minus x1. And literally, if it's a free response, you could stop there. And all that's left is like subtraction and division. But not a multiple choice. You'd probably want to be like, okay, yeah, that's 8/4, or that's 2. That's not bad, right? Let's say like number 4, just gonna let it freak people out. I've got from 2 to 7, because they're telling me one endpoint is 2, one endpoint is 7. If I plug 2 in up here, I get ln of 2. If I plug 7 in, I get ln of 7. If I do the slope formula, I get that, and that is an absolutely fine answer. They might have, I don't know if you guys remember how to combine subtraction with logs. If I want to narrow that down into one natural log, what would it be? Natural log of what? It actually combines to be division. They're powers. So if you're doing it, when you're dealing with logs, they're powers. So if you were doing a division problem, what would you do with those powers? You'd subtract them. So that's how the subtraction and division like relates. So they might have written it like that. They might have written it like that. But like those are all the same. What I care about right now is can you get to that and then some form of like simplifying it. So there's a couple more down here that are more from like tables or graphs. We do a couple of those and then so number 6, they're telling me between 3 and 13. So again, they're giving me 2 x values. And they're just giving me a table to find the y values instead of an equation. So what's the y value when x is 2? I'm sorry, when x is 3? 4. So that's just this point. And when x is 13, it's 10. And then you're just going 10 minus 4 over 13 minus 3. So it'd be like 6 tenths. Really just a slope. If it is from a graph, same thing. Let's do like 13, because I can see that tripping some people up. So I've got -4 is an x value, and I've got 0 is an x value. I do have a couple different graphs here, so this graph reading is a little bit tougher than normal. So I'm going to plug -4 into this. So now it's going to say, what is f of g of -4? Well, g of -4 means what's the y value when x equals -4. So make sure you're looking at the g graph. When x is -4, what is y? Yeah. For like leaving or temporary with this things? Okay. Yep. Cameron, go down to the office and bring your stuff. So when I plug -4 into g, what do I get? -2. So then it becomes, okay, what's f of -2? Because that's simplified to be -2. So now you're plugging that -2 in to f, and that would be 3. See how I'm doing that? Same idea for g, or for 0. So if I plug, have a good weekend. So it's going to be f of g of 0. So g of 0, I plug 0 into the g graph, I get a y value of -1. So that part simplifies to -1, and then I'm asked, okay, what's f of -1? So -1 in the f graph is also 3. So it's not no slope. It's a slope of 0, which is what kind of line? Don't say straight. God's sake.
I was gonna say.
You just said line. I said what kind of line, and you said line.
Well, it's better than the straight line.
I was gonna say
Is it?
it's flat.
Flat. You don't even have to say that, you just have to say 0. Are these okay? Do any more? Any more look like weird to you? Jump out at you as difficult? Have any more questions I can help you with? Crossed out a bunch of the hard ones, right? Nope. No more. No more getting rid of.
So no more